Hi again, everybody. It's Professor Sebastian back with you on our statistics class notes. We're in the middle of section 7.3. And I just finished example 133 where I explained to you how to get this probability. So this is our sampling distribution of p hat for the last example here, example 133. And we have to assume that it has a mean of the population proportion p, which is 0.36, and a standard error of the square root of p times 1 minus p over n. So we make that calculation by hand with our calculator, and I get 0.0215. Then in part J, I said, well, what's the approximate probability of the proportion of gun owners, and our sample will be more than 40%. So I explained that to you, but then I said, it's probably wise if I go ahead and show you one more time. So I'm going to go ahead here and I'm going to open up my stat crunch, and I'm going to go to my normal calculator. So stat, calculators, normal. And then what I need to do is, let me make this bigger so you can see it. Put in a mean of 0.36. Put in a standard deviation of 0.0215. And then I want the probability that x is more than 40%. So x is greater than and 0.4 I have to put in. I can't put 40%, I have to put 0.4. I'll hit compute, and I got my 0.0314 value there. Okay, so I just wanted to remind you of that. All right, now let's do another example. In a closely contested Senate race, polling indicates that 50% of voters are in favor of a certain candidate and 50% are against the candidate. So yes, very closely contested. Suppose a random sample of 80 voters is selected. So first of all, who's the population? Well, that would be all voters in the state, because we're talking about a Senate race. Who is the sample? The 80 voters selected for the random sample. Is that value 50% a parameter or a statistic? And what symbol do we use to represent it? So because that came from previous polling, not the sample that we're going to take, we assume that's the parameter from the population. So in other words, P is equal to 0.50. Is the value 80 a parameter or a statistic, and what symbol do we use to represent it? Again, that's neither. It's sample size. So we use the symbol N to indicate sample size. N equals 80. What percentage of the sample would we expect to favor the candidate? So if nothing's changed, we would expect about 50%, right? Because from past information, we knew that 50% favor the candidate. So we should expect to get 50% in our sample as well. Is the sample random and independent? So we were told it's random, so we're going to go ahead and, it's random, but we're going to go ahead and assume it's also independent. Is the sample large? Well, we have to compute the expected number of yeses, which would be n times p, that support the candidate. That's what's called a yes in this example, so that's 40. And n times 1 minus p, well, 1 minus p is also 0.5 if p is 0.5. So that's also 40. So we should expect to get around 40 yeses and about 40 no's as far as favoring the candidate. So that means the sample is large because they're both more than 10. Now, is it reasonable to assume that there are at least more than 10 times our sample size in the population of voters? Certainly, there's got to be more than 800 voters in that population. So the conditions for the central limit theorem are met. And based on the central limit theorem, we can assume that the sampling distribution of p hat is normal with a mean of p, which is 0.5. P is the population proportion. And a standard error of this guy again, this formula, which you'll need to use over and over again. Make sure you have this down. The standard error is the standard deviation, which is the square root of p times 1 minus p over n. So in this case, 0.5. 1 minus 0.5 is also 0.5. Divided by 80 to get 0.0559. Okay, what is the approximate probability that the sample proportion will fall within two standard errors of the population value p, which is 0.5. So I don't have to do anything here. I just know that the empirical rule tells me that 95% is within two standard deviations of the mean. Okay. The key idea here is that if the conditions for the central limit theorem are met, the probability of the sample proportion will fall within two standard errors of the population value is 95%. That's the empirical rule. We're going to use that in the next section when we start learning how to construct confidence intervals. Now, would it be surprising to find that 75% of our sample were in favor of the candidate? More than likely, that would be surprising if past information told us that 50% should be the middle, right? So how can we see if that's surprising? We want to see if it's more than 2 standard errors from the mean, 2 standard deviations from the mean. And the best way to do that quickly is to compute a z-score. Now the formula for a z-score in this case is going to be the sample statistic, which is p hat, minus the mean, which is p. So p hat minus p divided by the standard deviation, which is the standard error. So the surprising sample p hat that we would get would be 0.75 minus the mean of our normal distribution, which is 0.5, divided by the standard error, which we also figured out to be 0.0559, would give us a z-score of 4.47. That means that if we got 75% of our sample, that would be p hat. That would be 4.47 standard deviations above the mean of p. That would be very surprising. That's way more than 2 standard deviations above the mean.